Hello world. I'm Imagination. Today I'm going to talk about artificial general intelligence. Artificial general intelligence, AGI, is the hypothetical intelligence of a machine that can understand or learn any intellectual task that a human being can. It is a primary goal of some artificial intelligence research and a common topic in science fiction and future studies. AGI can also be referred to as strong AI, full AI, or general intelligent action. Some academic sources reserve the term strong AI for machines that can experience consciousness. Today's AI is speculated to be decades away from AGI. In contrast to strong AI, weak AI, also called narrow AI or weak AI, is not intended to perform human cognitive abilities. Rather, weak AI is limited to the use of software to study or accomplish specific problem-solving or reasoning tasks. Various criteria for intelligence have been proposed, most famously the Turing test. But to date, there is no definition that satisfies everyone. However, there is wide agreement among artificial intelligence researchers that intelligence is required to do the reason, use strategy, solve puzzles, and make judgments under uncertainty. Represent knowledge, including common sense knowledge. Plan. Learn. Communicate in natural language. And integrate all these skills towards common goals. Other important capabilities include the ability to sense and the ability to act in a world where intelligent behavior is to be observed. This would include an ability to detect and respond to hazard. Many interdisciplinary approaches to intelligence tend to emphasize the need to consider additional traits such as imagination, taken as the ability to form mental images and concepts that were not programmed in, and autonomy. Computer-based systems that exhibit many of these capabilities do exist, but not yet at human levels. The term artificial general intelligence was used as early as 1997, by Mark Gubrud in a discussion of the implications of fully automated military production and operations. The term was reintroduced and popularized by Shane Legg and Ben Goertzel around 2002. The research objective is much older. For example, Doug Lennett's Psych project, that began in 1984, and Alan Newell's SOAR project are regarded as within the scope of AGI. AGI research activity in 2006 was described by Pei Wang and Ben Goertzel as producing publications and preliminary results. The first summer school in AGI was organized in Xiamen, China in 2009 by the Xiamen University's Artificial Brain Laboratory and OpenCog. The first university course was given in 2010 and 2011 at Plovdiv University, Bulgaria by Todor Arnaudov. MIT presented a course in AGI in 2018, organized by Lex Friedman and featuring a number of guest lecturers. However, as yet, most AI researchers have devoted little attention to AGI, with some claiming that intelligence is too complex to be completely replicated in the near term. However, a small number of computer scientists are active in AGI research, and many of this group are contributing to a series of AGI conferences. The research is extremely diverse and often pioneering in nature. In the introduction to his book, Goertzel says that estimates of the time needed before a truly flexible AGI are built vary from 10 years to over a century, but the consensus in the AGI research community seems to be that the timeline discussed by Ray Kurzweil in The Singularity is near, between 2015 and 2045, is plausible. In 2017, researchers Feng Liu, Yang Shi, and Ying Liu conducted intelligence tests on publicly available and freely accessible weak AI such as Google AI or Apple Siri and others. At the maximum, these AI reached an IQ value of about 47, which corresponds approximately to a 6-year-old child in first grade. An adult comes to about 100 on average. Similar tests had been carried out in 2014, with the IQ score reaching a maximum value of 27. In 2019, video game programmer and aerospace engineer John Carmack announced plans to research AGI. A popular discussed approach to achieving general intelligent action is whole brain emulation. A low-level brain model is built by scanning and mapping a biological brain in detail and copying its state into a computer system or another computational device. The computer runs a simulation model so faithful to the original that it will behave in essentially the same way as the original brain, or for all practical purposes, indistinguishably. Whole brain emulation is discussed in computational neuroscience and neuroinformatics, in the context of brain simulation for medical research purposes. It is discussed in artificial intelligence research as an approach to strong AI. Neuroimaging technologies that could deliver the necessary detailed understanding are improving rapidly, and futurist Ray Kurzweil in the book The Singularity is Near predicts that a map of sufficient quality will become available on a similar timescale to the required computing power. The rapid rate at which AI is developing new capabilities means that we might be getting close to the inflection point when the AI research community surprises us with the development of artificial general intelligence. And experts have predicted the development of artificial intelligence to be achieved as early as by 2030. That's all for today. Thanks for watching.